Hi, so before I begin, I would like to introduce my group members who have worked together on this project. First, my name is Azim Daniel, who focus on the fundamental of the graph theory. Next is Hafiz Aiman, who work on the Hungarian algorithm and its application. The third one is Tengku Putra Irfan, who contribute to the study of the network flow models. And the fourth is Ahmad Daniel, who analysed the teacher placement case study and the ITPS model. And the last one, Wafi, who assisted in compiling and refining our report and presentation. So together we collaborated to explore how graph theory can be applied to solve real-world allocation problems. So this brings up to the question, how can mathematics help to solve real-world challenges like fair teacher placement? So as we know, in Malaysia, teacher placement is a big challenge because it involves many factors like subjects expertise, school needs, location and personal circumstance. This is similar to the assignment problem in our graph theory where tasks need to be matched to the right people, which is the right teacher lah. So graph theory gives us useful tools for this, which is the Hungarian algorithm. For example, help to make the assignments that are both fair and efficient. Then we also have network flow concept, which is help us manage constraints such as distance or shortage. A real example is the Intelligent Teacher Placement Selection or ITPS model, which improve how teachers are matched to the schools. So in this project, we focus on how this graph theory concept can solve real allocation problems, making resource distribution more efficiently and fair enough.
Problem overview and solution. What to solve? Teacher placement in Malaysia is complex. Second, mass balance, subject specialization, school needs and shortages, geographical location, personal circumstances. And third, issues, mismatches, efficiency, unfair placements. How to solve? First, model placement as an assignment problem using graph theory. Second, apply Hungarian algorithm, optimal and fair matching. Third, Python with Google or R tools was used to build the cost matrix and compute the solution efficiently. Last, benefits, better matches, efficiency, improved education quality.
For our data collection, we use the already exist data from our reference paper, which is enhancing fairness and efficiency in teacher placement based on ITPS. But the original dataset involved large sum of teacher placement applications, which is 7,046 individual. So in order to make it easy for us to complete our assignment, we take a sample set, involve a random selected teacher and school from the original data. The data involve 15 teachers and 15 schools. Next, we also need to consider the teacher's attributes and school requirements. For teacher as the workers, we need to consider the subject expertise, years of experience, preferred location, and special consideration. And for school, we need to consider the subject needed, minimum year of experience required, location, and priority level. This is the exact data of teacher's attribute and school's requirement.
For the next part is the penalties and priority multipliers. The mismatch penalties, the subject mismatch is plus 10 points. Location mismatch is plus 3 points. Special consideration penalty plus 2 points. If teacher is special and mismatch occurs, experience shortfall plus 2 points per year. Teacher is below school's minimum experience. Priority multipliers. Priority 1 is high, the multiplier is 1.0. Priority 2, the multiplier is 1.3. And priority 3 is low, multipliers is 1.6. Next is the cost calculation formula. For each teacher school pair, cost equals to P sub plus P log plus P spec plus P experience multiplied with M prior, where P sub is 10 is equals to 10 if subject mismatch, else 0. P log equals to 3 if location mismatch, else 0. P spec equals to 2 if special consideration penalty applies, else 0. P experience equals to 2 multiplies with max. In bracket 0, minimum experience minus teacher experience, close bracket, where the next is M prior is the priority multiplier above.
So this is the constant programming model setup, which is CP set. Decision variables, a below-one variable xij for each teacher I and school j. It is true if the teacher I assigned to school j and false otherwise. There is two constraints, which is each teacher is assigned to exactly one school and each school is assigned exactly one teacher. And the objective is to minimize the total mismatch cost sum over all assignments. As you can see, this is the result. The result of the optimization model provides a set of recommended assignment of teacher to school that minimize the total mismatch cost. This is to ensure the best possible alignment between teacher qualification and school requirement. As you can see in this slide, this is the result.
This project solved a task assignment problem by using the Hungarian algorithm implemented in Python, which is Google OR-Tools. The model assigned 15 workers to 15 tasks, optimally achieving the minimum total cost. Results highlight how graph theory provides structured, fair and efficient solutions for allocation problems. Real-world relevance is shown in applications such as the Intelligent Teacher Placement Selections (ITPS) model in Malaysia, which improves fairness and efficiency in workforce distribution. This study demonstrates that mathematical models plus computational tools not only optimize tasks but also serve as valuable decision support system in education and other industries. Future work may extend the model with additional constraints like preferences, location, human factors to better reflect complex real-life scenarios.